Hopefully you're back. You went, had a cup of coffee, maybe a donut, and you are ready to go for chapter 14, part 2. I'm sorry. I'm trying to be funny. It's tough. All right, let's get going. There we go. So, volcanoes can have two types of eruptions, and this is due mainly to the type of lava. So, I kind of talked about this a little bit, right? So, effusive volcanoes, those are the ones that are like Hawaii. So the lava is very thin and it flows quite easily. These produce shield volcanoes. The lava doesn't really explode. Now, you might have seen videos of the Hawaiian Islands where they've had some lava that explodes a little bit. There are once in a while some gas bubbles, but for the most part, the Hawaiian volcano that erupt, you can literally walk up to the edge of it. The only thing that keeps you away is the heat, but it's not blowing apart the island very much. The lava just flows out of cracks in the earth almost like water. The one that's worrisome and the one that causes more death and damage is an explosive volcano. And this is the type where you have that really thick lava that can kind of almost plug up the volcano, almost like if you put your thumb over the top of a bottle of soda and shake it up, right? And when it finally blows, the soda goes everywhere. Well, in an explosive eruption, that pressure can basically blow apart the whole mountain. So rock, ash, volcanic gas, and lava can be thrown up in the atmosphere. Sometimes they can actually be thrown as much as 7 to 8 miles up into the sky. And here's an example right here. This one erupts in. This one is from Montserrat in the Caribbean, and we can compare them, volcanic eruptions that is, by how much material they throw out. So how much ash, dust, gas do they put out? And they call it the VEI, Volcanic Explosivity Index. Okay. Now, here's some examples. Mount Pinatubo in 1991 in the Philippines, very big one. Mount St. Helens, it was the largest one in the lower United States since 1980. This one right here, Mount Tambora in 1815, was so intense that it put up so much dust and gas in the atmosphere that the next year there was no summer in the northern hemisphere. In 1815, the weather was so cold that in Virginia, in the middle of summer, the lakes and rivers were still covered with a foot of ice. Crops failed around the world. And then right here, this is the one that from the Yellowstone caldera I showed you about maybe 2 slides ago that covered most of the U.S. in ash. So you can see they can vary quite a bit in size. So the biggest threat besides the volcano literally exploding in your face are lahars and pyroclastic flows. A lahar is what happens when it's basically a mudslide, if you will, that comes from a mountain. If a volcano is tall enough, the top of it might be covered in snow. And if a volcano erupts, obviously that snow melts right away. So you get this big, huge rush of melting snow and water coming down, which turns the dirt around it into mud, and it mixes with ash and rocks. And if there's anything in the way, like trees or houses or anything, it comes down. And what happens is, here's an example. That eruption I showed you on the island of Montserrat, here's where it erupted. It came down the side of this mountain. It buried the capital city in about 3 to 4 feet, in some cases 6 feet, of this mixture of ash and mud. And when it dries, it's as tough as concrete. But the scariest one is a pyroclastic flow. And this is an avalanche of pyroclast and gas that comes down the mountain. And this cloud of basically ash and gases and dust travels about 500 miles an hour, and it can be 600 degrees, so that it basically incinerates anything in its path. So I've got this interesting little some images here. This right here is in Java, but there was a volcanic eruption about 2-3 years ago in Guatemala, and the pyroclastic flows left some really interesting trails behind. So let me pull up these images for you. So the volcano in Guatemala in 2018 is called Volcán del Fuego, which is just literally volcano of fire. It erupted, and right here, this pyroclastic flow went down the side of the mountain, and it went through a golf course and a couple of villages in its path. So this shows you the path of it. This area that's in light gray, these were areas covered in ash. But here's what happens. Here's the golf course that it went through before, and after. And it literally just burns everything to the ground in its path. This is a small village along the way. Burnt it all down. In fact, it's still smoking right here. So this volcano in the space of one day killed over a couple hundred people. So they can be deadly quite quickly. Close this down. Pyroclastic flows were also responsible for a large loss of life in Pompeii. Now, Pompeii was, in the year 79 AD, a resort city in the Roman Empire. It was basically the Palm Beach of the Roman Empire. And wealthy Romans came here. They had these beautiful mansions on the sea, and it's right next to where Naples is today. Now, the mountain of Vesuvius is still an active volcano, but in 79 AD, the eruption was huge, and the devastation was so vast that in the space of 2 days, it buried the town of Pompeii in about 15 to 20 feet of ash, which later hardened to rock. And it was actually forgotten. And it wasn't until in the 1700s, when a farmer was plowing his field, that his plow hit some old statues. They started digging and found this entire city basically preserved by the ash. And it's kind of unique because it happened overnight. So imagine if Chicago, I mean, obviously without the loss of life, but imagine if Chicago was basically encased in a rock immediately. The graffiti was still visible on the walls of the houses. But the other thing it did was kind of morbid in a way, and I'll go back to that image, was that people died in this ash flow. So this pyroclastic ash flow comes down, and basically people, they die, they fall dead right there. They're buried in ash. And so what happens is their bodies are buried in ash, and the ash hardens. It's almost like a cocoon. But what happens is, over the hundreds of years this happened, roughly 2,000 years ago, their bodies rot away, they're gone. And it leaves behind this empty hollow inside the ash. And so when scientists find that, they actually pour plaster in it, and they can make a cast of the people. So we've talked about this with hurricanes. We are getting very good at predicting hurricanes, when they happen, when they're going to hit. Can we predict volcanic eruptions? Well, we can and we can't. We can tell that the risk of it is getting higher because there's many things that happen. A volcano gives off signs. Usually there's increased earthquakes, the mountain begins to swell. It might have several small minor eruptions first. So many areas that are volcanic, there's lots of teams monitoring, like say Hawaii. Right here, they're actually monitoring gas samples. They're taking samples of the gas. Different types of gases are released at different parts of the volcanic eruption. It can tell you a lot about the chemistry of the volcano. Here, they're measuring how this crack in the ground, if it's gotten bigger. Here, they're actually using lasers, and they're monitoring the growth from a distance. So, Mount St. Helens, right here, this is near Portland in Oregon. It erupted in 1980. It still is the largest eruption in the lower 48 states that ever happened. A huge eruption. But what also made it unique was scientists had been monitoring it, and so they actually had a camera watching it, and they caught the eruption for one of the first times ever as it happened. So this video actually kind of talks about give you a sense of scale. This video is taken from over 3 miles away, so you can see how huge this mountain is. This is 3 miles away, and this is actually happening as it happened. So that was the eruption. That was 1980, and it blew apart over half of the mountain. It basically blew off the north half of the entire mountain. Now, Mount St. Helens was not done erupting. The eruptions have never been as severe because there's just less mountain to erupt. But it's still being monitored. So the next video I'm going to show you is actually a camera that the USGS, the United States Geological Service, set up to monitor the volcano. And you can actually see a brand new bulge forming in the middle of the volcano. So let me load that video. So again, the USGS set this up as a time-lapse image. So I believe it's 1 frame or 1 second for every day. And if you just watch right here, you're going to see this grow. It's just something you don't normally happen because it happens at such a slow scale. So every second is about a day. But there it is in the background. There's part of it growing there, right here. And it's going to start right here. Oh, look at that. Just swelling. So that's basically liquid rock and gas miles underneath, just pushing it up like a balloon, causing it to swell. It's going to get even bigger in just a second. Plus, you can see all that kind of gas is escaping from it, too. There's another one. Oh, there it goes. Look at that. So, it's still having many minor eruptions. Every once in a while, it'll pop out like that and still erupt. So, interesting. We normally don't get to see those things happen in front of us because they move so slow that we don't see it. Now, another interesting fact, and I've mentioned this before, is this idea of the Pacific Ring of Fire. Because of the type of plate boundaries around the Pacific Ocean, more than half of the Pacific Ocean is bounded by volcanoes, specifically the ones that are big and explode. Okay, so because of that, they often say the Pacific is surrounded by a ring of fire. And here's a couple different examples. This is a volcano in Mexico, and you can see its rate of eruptions pretty steady at a lower pace. This one's in Indonesia, again, very, very steady. And here's one in New Zealand. So all of these areas have lots of volcanoes that erupt at a pretty steady rate. So now we're going to move on to earthquakes. And I'm going to pause the video here so that you can get up and stretch and go have a cup of coffee or whatever. And then we'll come back for part 3 of chapter 14.